session. So all of the audio will be recorded, plus whatever I write on this drawing tablet will be recorded. As far as the problems that we'll work on, there's two ways to do it. You can verbalize them, and I'll write them on my drawing tablet, and then we'll go about solving them. Or if it's a problem such as interpreting, say they give you a piecewise graph and they want you to come up with a function, that's tough to verbalize. So if it's a problem like that, the best way to do it is for you to take a picture with your cell phone and send it to my email address. Now, the email address you should send it to is this one, just because this one comes directly to me. My digital math tutor one goes by Slow Boat to China method.
Okay.
So if you have anything you want to go over today that it would be easier if I had a picture of it, go ahead and send it right now to that email address and we'll take care of that. And then the next time we meet, it will be a lot easier for you to do stuff in advance and stuff. Do you have anything you'd like to take a picture of and send it to my email?
Let me check what I got.
Okay.
Don't we have the same book, huh?
What's that?
Don't we have the same book?
Could not understand what you're saying.
Don't we have the same book for GoToMeeting?
Let's see. Do we have the same algebra book?
I think so. It's like Google Little.
Okay, tell me what chapter and page you're looking at.
7.6, page 441.
Chapter 7.6?
Yeah.
So powers, roots, and radicals?
Yeah.
Okay. That starts, if I go to 437. All right. What page did you say?
441.
For what?
441.
441. Okay, I got a bunch of problems on there. What problem would you like to do? Boy, my audio is just terrible. Can you speak just a little closer to your phone?
Does this work?
Yeah, that's better. A lot better.
Okay.
Which problem? Let's make sure we have the same problems on this page.
Problem 23.
My 23 says x to the 5 halves equals 32.
Yeah, we have the same one.
Okay, cool. So is that where we want to start?
Yes.
All right. X to the 5 halves equals 32. How am I going to isolate x? In other words, I want the final thing to be x equals something.
When you put it into x to the fifth, x squared.
How about we just put an exponent on it that's the reciprocal of that?
Okay.
If I do it to the left side, I got to do it to the right side. Okay? Now, applying the rules of exponents, the left side becomes what?
1.
Well, x. That's what we want. What's 32 to the 2/5 power? How do I do that?
Would it be 32 to the 5th root squared?
Yes. What is the 5th root of 32?
2?
Yeah. All of these kind of problems, the numbers are always going to be 2, 3, or 4, okay? They're never going to ask you the 5th root of 196. If they're asking you 5th root of a number, you can bet the answer is going to be either 2 or 3. Okay? And it's not a bad idea to learn your powers of 2. It's pretty useful knowing that 2 to the 5th is 32, 2 to the 10th is 1,024, just because so much of the world is a binary world that knowing powers of 2 comes up quite a bit. So if I take the 5th root of 32, that's 2, square it, there's my answer.
Okay. And then I was wanting to look at
odd ones only or all of them?
Hold on. She has like this specific pattern. 26 is the next one.
Okay, let's make sure. That's minus 1/2 x to the 1/5 equals 10. Okay, good. Okay, what's first step?
Multiply it by the reciprocal.
Okay, so I can multiply it by -2 to get rid of it. In other words, I want to get rid of that. That's the same as dividing by -1/2. The way I tend to solve algebra equations is that's not a coefficient to me, that's a denominator of 2. So if I want to get rid of the denominator, I'm going to multiply both sides by 2. If I want to get rid of the -1, I'm going to multiply both sides by -2. Okay? So if all I'm doing is multiplying that part by -2, so I have to multiply this by -2. Now that gives me x to the 1/5 equals -20. What now?
So then you multiply the exponent by the reciprocal.
Yeah, that's called exponentiation. In other words, I'm going to exponentiate the left to the power of 5. Same on the right. That gives me x on the left, and it gives me -20 to the 5th power on the right. Is that a positive or a negative number?
Negative number.
Correct. And I don't know that she wants the exact number here. In other words, this might be a sufficient answer rather than having to go to your calculator and figure out how gigantic that number is.
Yeah.
Oh, you know what? It's got to be 32, doesn't it? It's got to be -32 with 5 zeros.
Oh yeah, because you basically just went over a simplified version of that.
Well, it's -2 to the 5th, which would be -32, and then all these zeros just end up being 5 of them. So -3,200,000.
Okay.
Okay. What's the next one?
Next one is 28.
X -4 to the 3/2 equals -6. Yeah, see, even these problems could be verbalized pretty easily if I did not have your book. But as long as I have your book, there's no reason to verbalize them. Although, you know, there is something to be learned on your end by verbalizing problems, in the sense that you probably never get a chance to do that in class. How often do you get to stand up in class and verbalize that problem? In other words, how exactly should it be verbalized? And the way it should be verbalized is the quantity x -4 raised to the 3/2 power equals -6. Or you could say left paren x -4, right paren to the 3/2 power. But there's things to be learned by verbalizing stuff. Okay, what's my first step here?
Exponentiate the 3/2.
To 2/3. In other words, you're always exponentiating to the reciprocal of that. That gives me x -4 on the left minus 6 to the 2/3 on the right. Add 4. There's my answer.
Okay.
Now, it's not a very pretty answer. I guess they did it intentionally. In other words, when you take these fractional exponents, the bottom number is always the root, the top number is always the power, But you got to be a little careful when you do something like that. You got to be really careful. In fact, if you do a little research, you'll find something that says you cannot take a negative number to a fractional exponent.
Why would that give you an imaginary number?
Let's just take a different example here. How would I do this problem?
Take the third root of it.
Which is?
2. Negative 2.
And then square it, so I get that, right?
Yes.
Plug that into Wolfram alpha and you do not get 4.
What do you get?
You get an imaginary number.
Why is that?
Well, it's not something easy to explain. It really is almost on the verge of calculus to explain it. Not even sure I can do it, but it's not necessary to do it. You give this problem to any teacher and they're going to tell you 4 is the answer. But if you delve into the problem a little bit more, you start doing some research, you find out that you're not supposed to take negative numbers to fractional exponents, ever. Or at least you don't get just the real answer. That technically should be one of the answers, but let me do something. As long as I'm telling you this, let me prove it to you. This is a little bit off the beaten track, although not really, because they gave you this problem. So, have you ever heard of Wolfram Alpha?
Yes.
It's a great site. It's a great calculator. Watch what happens when I do minus negative 8. Whoops. Minus 8 raised to the, what do I want to raise it to? The 2/3 power?
Yeah.
2 divided by 3. The beauty about Wolfram Alpha is it tells you what you put in, which a typical calculator does not. Okay, there's my negative 8 to the 2/3. Notice their result down here. It's minus 2 plus 3.4i.
Oh, wow.
Nowhere there do you see 4 as the answer. And the reason for that, well, like I said, it's extremely complicated. It's above Algebra 2 level. It's really more of a pre-calc answer. And it may have to wait until you get to that before I can adequately explain it as to why it's not equal to just 4. Now, as far as the answer they're going to want to see for this particular problem, that's a good question. I can't wait to see what answer. Oh, that's right. And this wasn't even a common number. This was 6 instead of 8. But same problem. In other words, if I make that a 6, I'm not supposed to be able to find that either. And the rules basically are is you do not take negative numbers to fractional exponents. So I don't know how they want you to do 28. Because that's the only way to solve it. And check for extraneous solutions. What's the next one you have?
Next one is 30.
Okay. We'll stick with these. Your teacher may not even know about that other little difficulty of well, she might, but I'll bet she doesn't. There's not a whole lot of people. I didn't know about it until just a couple of years ago. I've been around math forever. This is not going to be a similar problem because we don't have a negative number. So what's the first step here?
Divide by 3.
Okay, which makes 16. And then what?
Then exponentiate the 4/3 with the reciprocal.
Okay, and that gives us x plus 1 over here. What's 16 to the 3/4?
2 to the 3rd power, which is 8.
Which means x is equal to 7.
Okay.
I'm a little bit puzzled by their checking for extraneous solutions, because we haven't found any yet in any of these problems. In other words, the only, and I'm wondering if 28 isn't one of those. But every one we've done so far, we've only come up with one solution, right? So you don't usually have that. Usually you have two solutions, and one of them might be extraneous. But we've been coming up with one solution only. Now, in problems 32 through 46, there's radical signs. And when you have radical signs, you're much more likely to come up with extraneous solutions. Of course, a radical sign is just an exponent to the 1/2. What's the next problem you need to do? Let's go ahead and go to it.
It's 32 through 60.
Okay, let's do 32 real quick. What's our first step?
Square it.
Square both sides. And then if we check to see if the square root of 1 over 81 is equal to 1/9, it is. The positive square root. Okay.
Then it goes by 4s.
Okay, so
the next one should be
36 is next. The third root of x plus 40 equals -5. And you can leave it with a radical sign, or you can do it this way. It's a little easier if you use fractional exponents to see how to handle it. So what am I going to do here?
Exponentiate with 3.
Cube both sides.
Cube both sides, yeah.
Okay? In other words, we're going to cube this side, and we're going to cube this side. We cube the left side, we get x plus 40. Cube the right side, we get -125. X equals -165. And if we check that solution, it works. If I plug in a -165, then I'm taking the cube root of -25. Excuse me, -125. And the cube root of -125 is -5.
So it works.
Yeah, now see, there's something. In other words, I can take the cube root of a negative number like this. There's no problem doing that. That's equal to -5. It's when you have a fractional exponent that it becomes a problem. In other words, the one that presented the problem on Wolfram alpha was this, a fractional exponent. Because I can take the cube root of -8, even Wolfram alpha will give me -2 as an answer. But if I take -8 to the 2/3, it doesn't like it comes up with that complex answer. And I'm not even sure I fully understand why. But so far, the only one that's had anything to do with is 28. And I'll bet 28, they just give the answer as we, -6 to the 2/3 plus 4. Okay, so number 40 is next.
Yeah.
And let's see, we got about 10 minutes. So if it looks like we're not going to get to some that you consider harder and you want to jump to them, let's do so.
Okay. 46 on the same page.
Okay. This one I just wrote, we're going to move the 4 to the other side, divide both sides by -2, take each side to the 5th power. We'll have an answer. What I'm going to do here is a first step.
Square both sides.
Okay. What's the right side become?
X squared plus 25 over 36.
No, that's the most common mistake made in algebra, is squaring a plus b and coming up with a squared plus b squared. That's not what it is. In other words, if we take a plus b, two things, and square it, I get a squared plus 2ab, there's that middle term, plus b squared. Okay? Well, what we were squaring here is x plus 5/6. So the first term is x squared. The middle term is 2 times that, which is 10/6 x plus 25 over 36.
Okay, I see what that is.
Okay? Yeah, don't forget that middle term. That really is the most common mistake made in algebra, is that x plus 1 squared is x squared plus 1, and it's not. Okay? So, what now? How are we going to solve this problem now?
That's a good question.
What are we looking at? Quadratic, right?
Yeah.
So whenever you have a quadratic, you want to put 0 on one side of the equation and everything else on the other.
So
Okay?
just put it all on one side.
Right. Now, this is made a little more complicated by these fractions. So what's a good first step for me to do to get rid of all denominators in one step?
Multiply it all by 6.
Not by 6. That won't get rid of this 36. Multiply everything by 36.
Oh, okay.
I'm going to multiply the entire left side by 36, which gives me 72x plus 6. I'm going to multiply each term by 36, gives me 36x squared plus 60x plus 25. Now it's a piece of cake. Once you get rid of denominators, it makes the whole problem a whole lot easier. Now we combine everything. So I'm going to move everything that's on the left to the right. Gives me 36x squared minus 12x plus 19. Equals 0. Equals 0, right. And now we have a quadratic that we need to either solve by factoring it or solve by the quadratic formula.
Looks like it's going to be quadratic formula.
I'm guessing the quadratic is needed because 19 doesn't have any factors, but maybe not. Let's see. They'd have to both be negative. Nah. In other words, it would be minus 19 and minus 1. And the 19 could multiply. Now, I'm never coming to minus 12 in the middle. So I'd have to use the quadratic formula to solve for that. Now, because I'm using the quadratic formula, I'm going to get two answers. And
Yeah.
because this problem started out with a radical, definitely has huge potential to have an extraneous solution. There's multiple things that produce extraneous solutions. One of them is radicals, the other is absolute values, and the third is logarithms. If you have equations that have any of those in them, then you definitely want to be checking for extraneous solutions. In other words, whatever two solutions we come up with there, and it's because of the size of the numbers, it's not easy to come up with it, but if you check both of them and you plug it in, you will find that the negative is not going to work because we will not be able to take the negative or the square root of a negative number. And in fact, they're both negative.
So it would be an imaginary solution?
Well, not necessarily. In other words, as long as one of the negatives is less than 1/6, then we would have the square root of a positive number. But it's possible that, yeah, there are no solutions. In other words, if we come up with two negative numbers, and I know they're both negative. Oh, no, they're both positive, excuse me. If we were to factor that, it would be something minus 19 times something minus 1, and that produces two positive solutions.
Okay.
Even using the quadratic formula, I'm going to get a complex solution here. In other words, we can tell by analyzing the discriminant what kind of solutions we're looking at. Well, b squared is 144 minus 4 times 36 times 19. That's a lot more than 144. So we're going to have nothing but negative. So we're going to end up with two complex solutions, which means no real solution satisfies this equation. If you've had complex numbers or not?
No, not yet.
Not yet? Well, then no solution on this problem.
Okay.
Okay. If you'd had complex numbers, then maybe you put in the two complex solutions, although I don't know that you can take the square root of a complex number either. So just no solution on this, unless I've made a mistake. I don't think I have.
I haven't seen one yet.
Yeah. So anyway. All right. That's probably a good place to stop. Gives you an idea how the online plays out.
I like it.
Yeah, most of my students do. They like it a lot more, in fact. Much better than having me there in your face. So it just is for everybody, actually. But let's see if we can figure out how to fix the audio next time, though, because the audio is a little rough when we use my phone here.
I think it has something to do with the computer. So
maybe if you have another computer that you can try, it might just be a question of turning on your microphone on that computer. Which,
yeah, it might be like activated.
Yeah. Like I have a plug-in microphone that's got a power switch on it. And sometimes I accidentally rest my elbow on the power switch and the microphone goes off and I don't know it. So it might be something like that even.
Okay.
But yeah, let's see if we can solve that the next time we have an online session. And sounds like you figured out how to schedule online and everything else. So you're good to go. I've got your email address. This is the one you want me to use?
Here, one sec.
Here, let me make sure I've got what I got. pziegler@comcast.net.
Yeah, that one will work.
That works? Okay. I will, as soon as I get this file processed of the recording, I will send you a link for it to your email address. It'll be later on tonight. And then you'll have a chance to go and review it if you want.
All right, cool.
Okay? All right, Jake. I will talk to you next time I talk to you.
All right, well, yeah, thanks.
All right. Bye-bye.